Okay, so I was just going to make a couple of videos covering section 6.1 in your book. We're going to do what's called solving a triangle right now. There are actually different ways to do it that we'll see as we go through a few other sections in this chapter. For right now, in section 6.1, we're just going to do a pretty basic way of solving a triangle. And essentially the idea is when you solve a triangle, say we have this triangle right here and that's a right angle. If I want to solve the triangle, I want to be able to find all three sides and all three angles. Once I know all six of those quantities, then I can say I've solved the triangle. Like I said, throughout this section, there are several different tricks and methods we're going to use. For right now, we're just going to start with a basic one, and then in the next video I do, we're going to look at some applications of this solving a triangle, because there are some interesting applications we can use it for. So maybe to start with this one, suppose we know that this side is length 6, and this angle is 40 degrees. I want to solve the triangle, which means I need to find this angle, we'll say call it capital A. I need to find this side, call it lowercase a, and the hypotenuse we'll call lowercase c. I know three quantities because that's a 90-degree angle. I want to find the other three. And there are different tricks we can use. First off, if that's a right angle, it's 90 degrees, if that's 40 degrees. We all know the rule, the sum of the angles of a triangle is 180 degrees, which means if I know these two, I get that one for free. So let's see, if that's 90 and that's 40, that adds up to 130. So then A has to be 180 degrees minus 130 degrees. So A equals 50 degrees. And we get that one. We can fill that in. Now we just need to find A and C. There's different ways we can actually do it. You're going to need your calculator for this, so I have my calculator nearby. There's different tricks you can actually do. It essentially is up to you and what trig function you want to use. Let's see. Well, there's a 40-degree angle right there. I know this side of the triangle, and I'm trying to find that side. What trig function relates these two sides to 40? That's opposite, that's adjacent, so tangent. So we can say tangent of 40 degrees equals the opposite 6 over the adjacent A. Now just solve that. Make sure you do your algebra correctly. Multiply the A over, so you get A times tan 60 degrees equals 6. And then to solve for A, divide the tan 60. So A equals 6 all over tan 60 degrees. And now just throw it into your calculator. Bear with me as I hit buttons on mine. Let's see, 6 divided by tan 60 equals 3.46. So now I know A, I can fill that in, 3.46. Now I just need to find C. And now again, it's kind of up to you. You know trig, use whatever trig you want. If you want, well, I know this side and that angle. That's opposite, that's hypotenuse. So I could use the sine of 40 equals 6 over C. I could use the 50 down here and do sines and cosines and tangents, whatever I wanted with that one down there. But in this case, that's a right triangle. And we know two sides, which means we can just use the Pythagorean theorem. And that says what? 3.46 squared plus 6 squared equals C squared. So square those out, add them up, and then square root. See what you get. And again, here's where I hit buttons on my calculator. So we'll do second answer squared. Let's see, plus 36 equals 48, and then second square root, second answer. And this calculator is all messing up, so bear with me for 1 second. There we go. 47.98. So c squared equals 47.9716. Your answers might be slightly different based on how you round. That's okay. And now from there, just square root that. So equals, and oh, that's why. 1 second. 6.92. So C equals 6.92. And then we can fill that in over here. And there we go. And the last thing we could maybe check is, does our answer make sense in the context of the problem? Well, yeah, the hypotenuse is bigger than the other two sides, so we're good right there. The angles add up to 180, so we should be good. And again, we are going to make these problems more and more involved as we go and use more maybe advanced type tricks, or at least different tricks to solve them out. For right now, you know the sum of the angles is 180, you know the Pythagorean theorem, and then beyond that, just your right triangle trigonometry. SOHCAHTOA, solve everything out and you're good to go. We're going to look at another one. So let's see. Suppose now we do it backwards. So say we have this triangle right here, it's a right triangle. Suppose this is 6 and that's 9. Now I want to find this angle, call it A, this angle, call it B, and this side, call it lowercase c. Well, what do? In this case, I know two sides as opposed to two angles. So, Pythagorean theorem, like we just used. If I do the Pythagorean theorem, I get 6 squared plus 9 squared equals c squared. 6 squared is 36, 9 squared is 81, 6 and 1 is 7, that's 117 equals c squared, so c equals the square root of 117. Normally for our problems, we're good leaving it like that, but in this case, since we're solving the triangle out, just throw it into your calculator and approximate it. So, square root of 117, we'll go with 10.8. So C is 10.8. And now what do we do from there? Well, I want to find the angles A and B. I have all the sides, just use my right triangle trigonometry. It doesn't matter which angle you use, which one you start with, A or B, and which trig function you use, as long as you use them correctly. Generally speaking, I think students, and if you look in your book, they will probably use whatever information you were given, meaning you might not use the 10.8 if possible, you'd use a 6 and a 9. So just because I'm guessing that's how your book and Alex might do this, we'll do it that way. So we'll start with A, and let's see, tangent of A equals opposite, which is 9, over adjacent 6. So let's see, 9 over 6, that's 3 over 2, which is 1.5. And now I want to find A, we'll just do tan inverse. So A equals tan inverse of 1.5. And now bear with me. So let's see. Tan inverse of 1.5, 56.3. So A equals 56.3 degrees. So we can fill it in over here. And again, now all I need is B. If I want to use my trick again, just for fun or because I enjoy it, whatever, you can. Pick whatever sides you want, do whatever trig function you want, and you're good to go. Or, since this is a triangle, and I know this is a right angle, and I know that angle, I still know the sum of the angles of a triangle is 180. So add these up, subtract from 180, and that has to be B. So let's see. B is equal to 180 minus, let's see, 90 plus 56.3. It's It's 146.3. And then let's see, if you subtract those, I think you get 33.7. And there we go. So B has to be 33.7 degrees. And again, we've completely solved the triangle. We are gonna, like I said, make these more advanced, but for right now, the sum of the angles of a triangle is 180 degrees. The Pythagorean theorem, a squared plus b squared equals c squared, and your right triangle trigonometry, SOHCAHTOA. As long as you have that, you can solve these things out entirely. The next thing I want to do is look at some applications for solving these triangles, but that takes a little bit of explanation, so I'm going to break that up and put it in a different video since it'll take a little bit of time.